Hello, my wonderful students. So I've been asked this a lot, so I want to take a minute and explain how to work this problem. This problem is -5 a zero of f of x equals 2x cubed plus 11x squared minus x minus 30. So we're given a function and we're given a value, and we're testing to see if this value is a zero of the function. We're going to use synthetic division to complete this and to do this test. So when we use synthetic division and it gives you a value to test, that number is the number that you will be multiplying by each time. So that's the number we're going to put in the box, and we are not going to change the sign here. So because it's not in a factored form, it doesn't have x with it, then we're going to leave that number exactly the same, including the sign. Next, we're going to complete our synthetic division process by bringing down the coefficients of our function here. So this would be 2, 11, -1, and -30. And we're going to continue with synthetic division. So our first step of synthetic would be bringing down the first term, or the first coefficient there. So bringing down the 2, and then we're going to multiply by the number in the box. So anything that's here in this line is going to be multiplied. So -5 times 2 gives me -10. Again, anything that's lined up and down will be added. So 11 plus -10 just gives me 1. We're down at this line again, so we're multiplying by the number here in the box, which is -5. So -5 times 1 is -5. And again, we're adding. So -1 plus -5 is -6. Multiplying again, -5 times -6 is 30. And adding gives us a remainder of 0. So the remainder is really what we're concerned about with this particular question. Is -5 a 0? If the remainder is 0, then the number in the box, which is -5, or the number given in the problem, is a 0 of the function. So I realize this starts to get a little confusing when we're talking about a term or terminology of a 0 compared to the number 0. And the reason this is a 0 is because if I was to take -5 and plug it into the function itself, I would get my y value, my function value, to be 0. And that's what we're doing and what we're finding with synthetic division. This is called the remainder theorem. So the remainder theorem tells us that the remainder is the function value. So if our function value is 0, that is a 0 of the function. So that answers this question. My answer to this would just be yes. -5 is a 0. But I want to take this a step further because in some of the problems, it asks you to take it further. So I don't want to just test whether -5 is a 0. Maybe I also am asked, what is the quotient? So again, we get our quotient from the remaining numbers here. This first number is our quotient, or our term, our coefficient of our first term in the quotient. So if we're starting out with an x cubed, our quotient will start with a degree less than that. So an x cubed, if we go down or we subtract 1 degree, that's going to give me an x squared. I'm going to subtract another degree, and this next number 1 will be the coefficient for that one. So if I have an x squared, the next degree down is just x. My coefficient would be 1, and this is positive, so I'm going to put a plus there. Now, I don't really need the 1, so I'm actually going to erase it. And you can kind of determine that as you go. If I go another degree down, we have x to the 0, which means that that x or that variable is not showing anymore, and I'm just left with my constant of -6. So this is my quotient. And maybe we take it even a step further, and we say, I want to factor this quotient. So we're going to go through the factoring process here. This means that I'm going to factor by grouping. So I'm going to do this process again. If you know any other ways, that's totally fine. I'm going to bring the first term down and the last term down and add 2 blanks. And then my A in this problem is 2, my B in this problem is 1, and my C in this problem is that -6. So my A times C will be 2 times -6, which gives me -12. I'm looking for the factors of -12 that would give me B, and in this case is just 1. So I could sit here and list all the factors of 12, and I think I'll do that. Some of you probably already know what the combination is, and that's totally fine too. So my combination that will give me 1 is 3 and 4. We want to be sure about our signs. So if our A times C is negative, then one of these numbers, 3 or 4, is negative. The other one is positive. And what I generally say is if this B term is positive, then the bigger factor here is positive. So if my B is positive, and in this case it is, then my 4 will be positive and my 3 will be negative. So how do we know for sure? We know for sure by just testing it out. So our test is multiply the 2 to get A times C, which gives me -12, which that's true. So this works. And we're going to add the 2. So -3 plus 4 gives me 1, which is our B. So as long as those 2 conditions are true, then we know we have the correct numbers. Once we determine those numbers, we're going to use that to put in our blanks. So we have -3x and 4x. And again, I probably said this before, but if you're just watching this for the first time, the order of this does not matter. So I certainly could have put 4x first and then -3x. As long as you keep the sign with the appropriate number, you're good to go, and it will all wash out in the end, or work out in the end, okay? So from here, I have my 4 terms, and I can begin grouping. My first step of grouping is to group. My second step of grouping is to factor out the GCF in each group. So in this first group, I only have an x in common. The 2 and the 3 has nothing in common. So I'm going to write 2x squared, and I'm going to go ahead and write this as -3x and divide both of those by x. Now, if you can do this step without doing, or do this GCF process without doing this step, that's totally fine. All right, looking in our next group, we have 4x minus 6. In common is a 2. And I would have 4x minus 6 with both of those divided by 2. This is going to give me x times 2, and x squared over x is just x, minus 3, and these x's cancel. The next one is going to give me plus 2, 4 over 2 is 2, bring down the x, and then minus 6 divided by 2 is 3. So I know I'm on the right track because my parentheses match. So I'm going to factor out the new GCF, which is our common parentheses, 2x minus 3. And the numbers in the front here, x plus 2, become your other factor. So my quotient here is 2x minus 3 and x plus 2. So what if I said, hey, I want you to take this original function that I gave you, this expression right here, or this function right here, and I really need you to write it all the way out in factored form, completely factored form. So what does that mean? Well, I know that the function itself has a quotient, and I know that the quotient is factored like this. So I do know that 2 of my factors is 2x minus 3 and x plus 2. But if I was to multiply that back out, that's not going to give me my original function. It will just give me my quotient. So what is my other factor and where do I get it from? And the way to think about this is if -5 is a 0 of the function, then -5 has to do with a factor of the function. So what we're going to do is basically say x is -5. So how would I write this in factored form? Well, I want to set this equal to 0. So if I needed this set equal to 0, I could move this over I would have x plus 5 equals 0. And this x plus 5 right there becomes your other factor. So this is going to go right here in our factored form of our function. And now we have all three factors. If we wanted to go further, we could set each of these factors equal to 0 and actually find out the zeros or the solutions when we would say f of x equals 0. But for now, I'm going to stop. So if it just said factor this function, this is actually the process for doing this. Again, two of the factors come from the quotient. The other one comes from the number that you got a 0 remainder. And you have to basically change the sign when you put it back with the factor, and that's because of this concept right there. All right, so let me scroll up and you can see that one more time. 2x minus 3, x plus 2, and x plus 5. So that is our factored form of the function.